It's a pleasure to be here. I'm really excited to make it out to a USENIX. And I'm excited to talk to everybody about SaltStack. Now, has anybody in here ever heard of SaltStack before? Oh, good. I've got a fair number of hands here. We've got maybe half the folks in here. Excellent. That's going to be fun right there. So I'm going to apologize in advance. I just bought a brand new Mac. I've never used a Mac before. I've always been a Linux guy, so I'm going to fumble something, I'm sure. But anyway, what I want to talk about today has to do with what the real requirements are of modern infrastructures and what is going on with respect to needing to deal with scale, needing to deal with a lot of the integration needs that are out there, as well as dealing with the diversity of clouds as they stand. So what I'm going to do is, instead of go through an early introduction of what SALT is and how it works, I'm going to do that very briefly. But I'm going to talk about some of the topological features and capabilities of SALT, some of the reasons why it's very apt and powerful when it comes to infrastructures that need to grow or be highly dynamic, and which is some of the reasons why some of the largest infrastructures in the world rely very, very heavily on SALT for their day-to-day work. So, as we get going, a modern infrastructure has a lot of really hefty requirements. There's this camera over here I guess I'm supposed to stay in front of. I'm used to walking around. And so SALT has been engineered to approach these requirements and meet these requirements. Now, orchestration requires extremely fast remote execution. One of the core things that SALT has been created to do is be able to execute in parallel or in serial across many, many systems at breakneck speeds. One of our favorite speed comparisons was that SALT was compared to an older tool being used in one of Harvard University's high-performance computing labs. And what took an SSH-based tool about 15 minutes to execute across 1,800 systems, they were able to replace with SALT, and SALT took roughly 5 seconds to execute. Now, the benefit here, if you have constant, ridiculously high-speed remote execution, is that all of a sudden, everything in your infrastructure is constantly at your fingertips. You're able to discover anything that you need virtually instantly. You're able to get real-time stats. You're able to do things very quickly. Now, then we come and we start and look at the fact that SALT is delivering a very powerful configuration management system. And so SALT's configuration management system is made. Everything is written in YAML by default, but it's all based around data modeling. And so again, I said I wasn't going to go into a lot of depth here, so I'll skim it really quickly. But the core idea behind the configuration management in SALT is that you define the data model for how something is going to work, and that data is inherently agnostic to how we get to it. SALT doesn't care how that model is achieved, which inherently makes SALT language agnostic, meaning that by default you can define everything in YAML. It's very simple and straightforward. If I've got some time, I'll go over some of those. But since it's language agnostic, if you want to, SALT comes with a Python-based DSL that you can use instead. It also means that it can be written in a declarative or an imperative fashion. Okay. Scalability. I've got, my next slide is actually, oh no, there's one between that. But anyway, we're going to talk about scalability and some of the techniques that SALT offers to allow it to scale into the not only thousands and tens of thousands of systems, but where we've actually got some of our clients starting to use SALT across over 100,000 server nodes. Now, SALT has the capability of executing continuous deployment. We're going to talk about the Wikimedia approach a little bit, and basically how Wikimedia is using SALT today to actively deploy new code out to Wikipedia. Okay. Since we have high-speed remote execution, we're able to monitor things in an impressive way. We're able to get real-time stats on anything and everything that's happening in the infrastructure. All right, and a few of these others I'm going to get to. I need to get a move on here. All right. So all of the communication inside of SALT is based around ZeroMQ. Now, what this means is that we're able to create a very high-speed asynchronous communication bus. I'm going to admit it's taken us a little while to get some of the kinks worked out of ZeroMQ, but at this point it works fantastically well. And I always like to mention how great a job Peter Hitchens and his team have done maintaining the ZeroMQ libraries. Now, another benefit of taking this approach is that SALT has been made in such a way to create the lowest possible network impact that we can. We don't want a lot of heavy load going over the network, and we want the lowest possible impact on target systems. Okay, and I've already talked a little bit about the configuration management. But basically, it's made to be data-driven, and it's made to be easily abstractable. All right. Now I'm going to start talking about some of these core components that we work with inside of SALT to accomplish some of these goals. So SALT itself does have an agent. Wow, that's coming up blurry. It does have an agent. This says servers down here. That goes out and runs on the client systems. And then a master that connects and controls all of them. Now, you don't need to declare, the master itself doesn't need to be aware of all of the minions that are there. They sign in, check in, you approve them, and then you can access or target those systems in a vast array or by many different means, whether it's by defining groups that you want to associate with, or if you want to target them based on system properties. There's many, many options. Now, when we start to look at deployments where we're getting beyond the hundreds of servers, and even we have some people using this down in the hundreds of servers realm, not for scale, but for flexibility across multiple data centers or cloud providers. And so it makes a lot of sense to have local controllers that are dealing with the directly connected components, or to group those out. And so SALT comes with a tiering system that allows it to very, very easily scale to very large levels, which again is one of the reasons why some of these larger infrastructures have decided to go with us. But the idea here being that you can have a SALT master, which is your main SALT controller, controlling its own group, and then it subsequently hooks into a higher level component or a high level master. Now, again, the benefit here is that you can have data centers strewn across the country that are all very efficiently able to be controlled from one central location, but still have the capability of going back and having local control over those infrastructures. Okay. Now, this is the continuous deployment model. That's right, this is the how Wikimedia does it slide. Now, continuous deployment inside of SALT is very, very simple. It's easy because you have a lot of different bidirectional control as to what's going on inside of your infrastructure. Instead of taking the approach of a purely agent-based or a purely top-level approach, SALT allows a lot of bidirectional communication. And so it's very easy to open up communication such that something that happens out here in your infrastructure can alert something else. So you're able to look at a central repository, say Git, Mercurial, BZR, whatever, that has code in it, but also can have all of your deployment information. So all of the information about your SALT states that are being used for your configuration management can be placed in this central location. The SALT master automatically brokers that relationship. You would technically never need to log into the thing to actually execute or to update commands. Now, the benefit here is that we're able to start to create a no-touch deployment environment. So, it's very easy for the master to receive information from a Git hook that says something is ready to go, or as we go closer into the model I'm trying to describe, it's very easy to say, as soon as a certain test executes successfully out on a Jenkins server, then, given certain properties that have been configured with that test, it's easy for that Jenkins server to inform the Salt master that we are ready to deploy fresh code. And so the Salt master is then configured. In the case of Wikipedia, they've got a few custom things around how they do it. You can go and see it online. They call it git deploy. But what it does is it allows it to automatically detect what systems need to be updated, update subsets of those systems, automatically test that they've been successfully updated before pushing the rest of the rollout. And then, another thing that I don't have on this slide that Wikimedia uses is the return interface. So it's very easy to say that we're going to execute something out in our cloud or our infrastructure, whatever it is. And once we're done with that execution, we don't care about the information coming back to this master server. We want it to go to an arbitrary database or interface. And so in Wikimedia's case, when they deploy code, all of their systems report into a Redis database, and that's all brokered via Salt. Now, the great thing here is that we're able to take advantage of external databases and external interfaces and ingest information in a very clean way. One of the reasons why we can do this is because everything that happens inside of Salt is JSON serializable. And so the end result is that that information can easily be transferred, ingested from, transferred to, whatever, virtually any database, any data store, any interface. Now, something that I began to allude to is that another one of the benefits here inside of Salt is the fact that we can have cross-communication. Now, by default, we've got a Salt master here, which is the thing that's pushing out commands and information out to Salt's minions. Now, that's a pretty standard push approach. But let's say that one of those minions out there needs to be able to find something out about its peers. Or let's say that that minion has been granted authority to execute jobs on its peers. So Salt can easily be opened up to do this, so that one of these guys can say, hey, I want to execute something on some other targets in the infrastructure. Now, obviously, by default, that's all turned off. That's kind of a security issue. But if it's allowed, then it's able to send that execution through, run it on the target, and get that information back. Now, some of the benefits here is that, again, it's very easy to start creating a very dynamic and reactive infrastructure, but also you're able to get live system information about what's going on in your infrastructure. You're able to say, be doing config management out on this guy, and one of its routines may say, hey, I'm the load balancer. Before I configure myself, I want to double check all the web servers that are out there and tell me everything about tell me what their state is and react in line so that we're able to execute routines very independently out on the edge systems. And they're able to execute routines on live data, information about what's really going on in the infrastructure right now. And again, that's something that we really are only able to achieve because our remote execution is fast enough to pull it off. Okay, now these last two slides are kind of associated with each other. Does anybody have any questions? Well, after the last talk, I'm glad I'm not the only one. Maybe you guys just aren't talkative. Okay, I will keep going. Now, there is this concept of a CMDB that's been around for a long time, obviously. We have started to see some of our users and customers to move completely away from the CMDB concept and say that their network is the CMDB. Salt has the capability of storing information in different locations in a very, very efficient way so that it's easy to store information that you would normally put in a CMDB literally out in your infrastructure, which makes it easy to just say, hey, tell me all the systems that are in a certain tier, and it responds instantly. We've got a number of interfaces that are available to store information depending on its level of complexity. Now, with that said, it's also extremely easy for SALT to integrate with an existing CMDB. And so, inside of the SALT master, there are a lot of different tools that allow you to hook into an existing database or an existing CMDB, gather data, and then reassign that back out to individual minions. This means that you're able to create direct associations in a very natural way. Again, one of the main goals behind SALT is that if a minion has awareness, or I should say, sorry, I keep saying, I mean, that's what we call them, they're minions because it's fun. I actually got some smiles out of you guys. Okay. But the more self-aware they are, the better equipped the edge systems are when it comes to configuring themselves, getting themselves going, and hooking information back in. Okay. So, integration can be done in a very, very simple way. Right now we have we have hooks for quite a few databases. All of the MySQLs, Postgres, of course. I can't mention MySQL without saying Postgres. If you ever want Postgres guys to do a lot of work and get excited, say MySQL has better coverage somewhere, and they get all uppity. It's hilarious. They're great guys. Anyway, Mongo, Redis, the NoSQLs are in there as well. All right. Now, something else that happens and is, again, very, very important inside of a scale infrastructure is the need for high availability of all components. Now, this is a fairly recent addition to SALT, but it has the ability to actively have a master tier so that it's very, very easy for SALT itself to be highly available. Any of those systems can be actively torn down and brought back up, and it's not going to have any impact on the management of the underlying infrastructure. The underlying infrastructure is still going to be able to cross-communicate, receive commands, and do everything that it needs to do, given the master interfaces that are available. All right. Now let's see if I can spend a few more minutes on this one. This is where things get a little more complicated. I shouldn't say complicated, powerful. One of the goals behind SALT is that it is extremely simple to set up and get going, but it's got a deep rabbit hole. We have every intention of providing as many interfaces as we can to the end users to satisfy the needs and requirements of their infrastructures. So, I'm going to talk briefly about the SALT reactor system. Now, the idea here is that SALT maintains an event bus. So whenever an event happens out inside of your infrastructure, that event can go and get fired on the master server. Now, the benefit here is that we're able to create events that we can react to in an extremely open-ended way. And so we can automatically detect if, say, components of our web tier have started to go down. We can automatically detect simple monitoring aspects of an infrastructure and then react to them. Whether that reaction is going to be to go out and fix that component automatically or to alert somebody is completely open-ended. Or whether or not that reactor is going to communicate with cloud systems. So one of the components inside of SALT is called SALT Cloud. SALT Cloud allows you to integrate with virtually any public cloud system out there today, including EC2, Rackspace, OpenStack, of course, because Rackspace is in there, CloudStack, Eucalyptus, etc. Linode, the list goes on. There's lots of them. Okay. But so the reactor allows you to also build in logic to work with automatically scaling an infrastructure across a cloud, whether that be a private cloud or a public cloud, and whether those hooks need to occur inside of a private OpenStack infrastructure, or even in some cases we have people using this in entirely custom private infrastructures. Okay. So, is anybody giving the time? 3:06. 3:06? Thank you. Excellent. I'm going to dive into showing how a lot of these individual components work. Now, any questions before I keep going? I've kind of spewed out a lot of stuff. All right. Now I'm going to go back to the top here and back up to the configuration management. See where, yeah. And start going over a couple of the components with respect to how the configuration management is defined. Okay. This is going to be fun. We'll see if we can get this to even work the way I want it to. Yeah, this is, I'm excited. There we go. All right. So we have a location on GitHub. Salt is open source. All of the code behind Salt is open source, and we just recently started the SaltStack formulas organization up on GitHub to collect and show off as demonstrations how to best and in a very easy way configure and use Salt's config management system. So I'm going to start by seeing if I can navigate through this in a pretty simple, let's see. Here's a fantastically simple beginning example. All right. So inside of Salt we have these files which contain all of the configuration management information. Now I mentioned earlier that Salt is inherently language agnostic. By default, again, everything is in YAML and written in a declarative format. The goal is to make it as easy and straightforward to read as possible. So we've got some pretty basics in here. This one has some Jinja templating in it. Now, in this case, we're saying that we've got something called Git. It's a package that we're going to make sure is installed. And the name of the package changes depending on what operating system we're on. One of the things that Salt does do is we see that we're using package right here to say that we're going to be installing a package. Salt will automatically map the underlying system's platform routines to consistent interfaces. And so you can say package.installed, and it's going to know to use Yum on Red Hat systems. It's going to know to use apt on Debian systems. It's going to know to use emerge on Gentoo systems. It's also going to know to use the package management system inside of Salt on Windows systems, so that it's, again, automatically able to deploy code on or deploy software in a Windows infrastructure. Okay? So you don't need to know when you're writing these necessarily. Obviously, in this case, this is a perfect example of they've named Git different things. So we've got to map it per platform. But you don't need to know whether it's apt or Yum or a Windows package manager or whatever when you're going into the situation. But so again, it's very straightforward, it's very simple. So let's go back here and start to look at a few of the more complicated examples. So for instance, we've got an example here of how to set up a Jenkins stack. So, again, the idea is to make it hopefully as simple to follow as we've been able to imagine, where we're declaring that there's a name of some things that we're going to be doing here, a file in this case, we're making a directory, and the information about that file. Now, by default, Salt uses a declarative approach. Now, the nice thing about this is that it makes it extremely easy to abstract away all of your individual components and to create relationships. And so we see here that we're saying, all right, we're going to make sure this directory is here, but only after those users and groups are set up. Okay, here's something that's a little more powerful. We're able to say we've got a repo that we're managing, and then pass in different values depending on the underlying platform. So in this case, we're able to automatically say, all right, we're going to have these repositories with these values get realized on the system and manage it differently depending on whether or not we're a Red Hat type operating system or a Debian type operating system. Okay, any questions so far? Do we do plugins? Oh, sorry, what?
Plugins on Jenkins.
Oh, Jenkins plugins. I don't have any examples of installing Jenkins plugins right here. Actually, I don't think so. We actually just accepted some pull recs here, and I haven't been watching this one as closely. This guy has been going nuts on these. Anyway, yeah, we have an extremely large community. Salt is just a little over 2 years old. Last year it was named the 8th largest developer community on all of GitHub, which put us actually right behind OpenStack Nova, which was something that we were really excited about. I'm using the USENIX one. Should I be using a different one?
Using 5 gigahertz works well.
There we go. Now, let's see. So the next thing I want to do is do a quick introduction of how to get started with Salt, and then we'll call it a wrap because I think I'm running at about 15 minutes. Now, Salt is a very extensible and a very powerful system. And we have somewhere in the realm of 700 pages of documentation, which is far more than you need to read. Good land, yes. The idea here being that, again, there's a lot that it can do. It's a deep rabbit hole, but it is not hard to get going and get things working. So, docs.saltstack.com is the place to go to get started with Salt. Now, before I dive into the tutorial here, I will mention that if you want to find some of the deeper stuff, you can go to the table of contents, and there's a lot in there. We also have a whole series of tutorials. There we go. There's lots. We mentioned also every module, everything inside of Salt that you can use to configure your system is thoroughly documented here. Right now, and Salt breaks things up a little differently. It's got execution modules and state modules. Right now we have well over 200. Okay. Now let me go back. If I can, there we go. This is not the easiest navigation situation. All right. Now, the first thing to do when getting started with SALT is connect to the internet. There we go. All right.
There's a question online.
Oh, yes.
Is Salt's dependency on pre-installed minions present a challenge for managing these entities? Installation, monitoring, updating, for example. Does Salt have any predefined tools for dealing with these?
Okay, yes. Salt does have a lot of tools to deal with this. If you go onto our GitHub page, there's a project called Salt Bootstrap. And Salt Bootstrap can be used. It's a script, you run it, and it will install the Salt minion on a target system, and it will install the Salt minion the right way for that target system. It will automatically detect what the operating system is, add the right package repositories, and install it via a package install. Also, there are routines inside of Salt that make updating your minions very, very easy and seamless. Salt has been architected from the ground up to be able to salt itself. It's the problem with an online question. You can't, is that good? Now, any other questions? Okay. Now, really quickly, we have a series of walkthroughs that are very, very brief. Only going through SALT and reading about 5 to 8 pages of documentation, you should feel very confident in getting going and starting to set up a solid infrastructure using SALT. So, I strongly suggest, again, just looking through the walkthrough. Again, it's thorough. It takes you through some examples and explains how all of these components are coming together. All right. Whoops, too far. So, before I get going, last call for questions. I think I may have talked a little too quickly. I apologize. But yeah, any questions online? Anybody, any comments, rebuttals? I don't want an argument, but if you want to, yeah.
So I'm looking at
So a lot of the features that you're emphasizing seem to be on remote execution rather than on sort of a model of consistency or whatever. How would you compare what you're doing with like write scale, for example?
Okay. So let's see. Probably the biggest difference between the SaltStack approach and what RightScale is doing. You'll have to forgive me. I haven't spent a lot of time with RightScale. But it's that SALT is meant to be a generic and very open-ended execution system in that you're able to easily plug it into a lot of different routines. And so when we go back and we look at, for instance, the reactor, which can be used to really help define how big a cloud is and things of that nature and define how to react to those situations. It's, again, made to be open-ended, to say, we're going to translate what comes in and decide if we're going to react on it, instead of having more predefined rules. Now, with that said, we are in the process of developing more and more predefined rules for the reactor in specific, so that it is a lot easier to say based on, say, number of Apache connections, instead of where it is now, again, which is very open-ended. Does that answer your question? Okay. All right. Oh, looks like we might have another one.
Monitoring and grouping minions seems to be the other issue with SALT installations. It seems that it could be very complex and hard to deal with the environment. Any comment?
Sorry, monitoring and grouping, it seems it may be hard to deal with the...
Monitoring and grouping minions seems to be the other issue with SALT installations. It seems that it could be very complex and hard to deal with the environment. Any comment?
Okay. So when it comes to grouping minions, there are a lot of options with respect to how someone can do it. And so minions can be grouped either by system properties or explicit lists of their names. So every time a minion checks in, it has an ID. And so there's a number of techniques that people use to accomplish the goal of grouping these. One of them is to set a value on all of the minions for specific groups. So those minions are self-aware of the groups that they are in. So whether they're connected or not, they're going to respond to being inside of that group. Another option is that you can statically write out lists of minions. Now, if we look at, for instance, LinkedIn's infrastructure, they use an external server to categorize and manage all of their minion groupings on their behalf. And so the end result there is that they've got an outside system that is then feeding them in targeted lists of groups, so that they're able to, again, target very specifically. But yeah, the goal there again is that it's an open-ended way of targeting, which makes it very powerful. It gives you a lot of options as to how you can go about doing it. Okay. Yes.
So I'm wondering, how would you deal with things like instance scaling? For example, in Azure, you can say I want between 1 and 7 instances of something, where the cloud infrastructure, actually the fabric layer, decides when to create a new instance. Does SALT accommodate that, like having things magically appear on you?
Yes. So yeah, you can have it so that it's actually pretty trivial. If a system boots up and it has and a minion's been put on it, so it's going to check back in, and that bootstrap process is thoroughly automated. So again, it's very, very easy to do. So that system comes up and it hooks into the master. It's easy to configure the master to say that it received an event from someplace else to say, hey, this guy's about to come up, accept its key. It's very easy to put auto-acceptance routines in there, so if it's fitting a certain range of criteria, then it automatically gets accepted. So that you are able to have an external resource safely and securely spin up new virtual machines and then bring them back into under SALT's umbrella.
What happens when they go down?
Okay. When they go down, then they're not there anymore. They're still authenticated on the system, but since they can't be accessed, then SALT reports them as down.
Right. So you can't distinguish between something that's being reached by the fabric and something that's crashed.
Yes, it can, because you would be using SALT Cloud to determine what is being managed by the fabric, and then you can compare. And then, okay. So one of the routines inside of SALT Cloud is to compare what's being managed, there, and then come back and see what's being actively used inside of SALT. So it can make those comparisons.
So it plugs into the fabric.
Yeah.
Yeah.
Okay. Unless there's any other questions or comments, I think this is a wrap. What are we at, 5 minutes? Okay. Thanks.